fractional linear equations. Let's check it out. All right, so solve for x in simplest form. Okay, so whenever it says simplest form, that means that they typically want it to stay in as a fraction. If our answer is a fraction, it should stay as a fraction. So we've got 5 equals 1/2 times 7x plus 4. 5, let's see here, we'll hop over. 5 equals 1/2 times 7x plus 4. All right, well, I could distribute. Let me make sure I wrote, yep, okay. I could distribute, or I could say, hey, multiplying by 1/2, I know the inverse is multiplying by 2, right? Dividing by 2, multiplying by 2. If I do it to one side of my equal sign, I do it to both. 2 times 5 is 10. This 1/2 and this 2 divide out to give me 1, so equals 7x plus 4. Now now it's down to just a two-step equation, right? Doing my inverse operations to get x by itself. Right, so I want to undo the added or subtracted term first. So that's this plus 4. The opposite of plus 4 is minus 4. 10 minus 4 is 6, and I've got 7x. 4 minus 4 is 0, right? So 7x plus 0 is just 7x. My goal is to get x by itself, so I have to get rid of that 7. The opposite of multiplying by 7 is to divide by 7. If I do it to one side of my equal sign, I do it to both. And so 7 divided by 7 is 1x, and 6 divided by 7 doesn't reduce. We can just leave it as 6/7. Delta Math does not want it as a decimal. They want it as a fraction in lowest form. And there you have it. Okay, and Delta Math walks you through the whole big long process. It looks like they did the distributing process, which is fine. You could certainly distribute. I just thought, hey, it looks much easier to just multiply out by 2 to get rid of that fraction right off the bat. And let's see here. It looks like most problems you can do that with. If you don't like this fraction out in front, you're just multiplying, right? You're just doing the inverse of dividing. So here you'd be multiplying both sides of the equal sign by 6. This problem, you'd be multiplying both sides of the equal sign by 2, right? Whatever that denominator is. For this problem, this equation, you'd be multiplying both sides of the equal sign by 2. Now we're multiplying both sides of the equal sign by 5. Okay, so sometimes using a little strategy can help you get there faster. Now, for this equation, we can still get rid of that denominator by multiplying both sides of the equal sign by 3, but it's going to work out a little differently. So I'm really glad that I saw this before I exited out. Let's check this one out together. So 4 equals 2/3. 4 equals 2/3 times 2x minus 9. 2x minus 9. And let's see here. Working this out, we could multiply both sides of our equal sign by 3 to get rid of that denominator. So 4 times 3 is 12. But when we do that, the only thing that we got rid of was that denominator. So we still are going to have to do some distribution here. Or if we don't want to do the distributing, we could say, hey, this 2 is being multiplied. The opposite of multiplication is division, right? So 12 divided by 2 is 6, and 2 divided by 2 is 1. So I'm left with 2x minus 9. And now, welcome to my tornado. As you guys can hear my daughter running around in the background. So anyways, now you can see, okay, we want to get rid of our added or subtracted term first. So I'm going to get rid of that minus 9 by doing the opposite, which is plus 9. If I do it to one side of my equal sign, I do it to both. 6 plus 9, that's 15, equals 2x. 9 plus 9 is 0. So 15 equals 2x plus 0 is just 2x. I'm going to get rid of that 2 by doing the opposite of multiplying by 2, which is dividing by 2. 15 divided by 2 doesn't divide nicely, right? That would give me 7.5. It doesn't look like it really reduces any either. So at that point, since Delta Math said they want us to leave it as a fraction, we would just write it as 15 halves. Of course, I always like to check my work by plugging back in, right? So 4 equals 2/3 times 2 times 15 halves minus 9, right? So let's see here. Following order of operations, please excuse my dear Aunt Sally. My daughter is wild. I know, hey, 2 divided by 2, that works out nicely. So I have 15 minus 9. So 15 minus 9, that gives me 4. Nope, 6. Sorry about that. This should be, whoops, oh gosh, now I'm making all kinds of marks. This should actually be the number 6. I'm going to rewrite it over here. 4 equals 2/3 times 6. Sorry, my daughter distracted me. Blame it on the kid, right? So 6 divided by 3 gives me 2 times 2. And 2 times 2 is 4. 4 equals 4 is a true statement, so I know that 15 halves is the correct answer. 15 halves. Enter, enter, and it worked. And that is fractional linear equations through a tornado of a 3-year-old.